Hello, my dears. So let's continue the topic, the method of consistent deformation on truss with two redundants. Okay, yesterday we discussed it with one redundant. Today we are going to discuss it about two redundants. So this is a question. Four wires AO, BO, CO and DO supports a load of 40 kilonewton as shown in figure. The cross-sectional area of each member is 2000 mm square and E is 200 kilonewton per millimeter square. So this is the question. So AD is a wall. That means the truss is supported on a wall, that is AD. Then OA, OB, OC and OD are the members of the trusses, and here there is no external supports are there, and it is supported a 40 kilonewton load externally. Okay. Then, how will you determine the external indeterminancy? It's equal to number of unknowns minus number of equilibrium equations available. Here we know there is no external support. So, external indeterminancy cannot be determined. Then go for internal indeterminancy. That's equal to m plus r minus 2j, where m is the number of members. Here we have 4 number of members and r is the number of r is the number of external reactions, and here we have no external support, so r is equal to 0, and j is the number of joints. Here we have only one joint is there, so internal indeterminancy is equal to 2. That means here we have to select two internal members as the redundants. Okay, so I am going to consider OA and OB as the internal redundants. Then next target is to find out the internal angles in the trusses. By considering the triangle ACO, we can find the angles AOB and BOC, and here we have the angle COD is equal to 45 degree. Then find out each diagonal length, that is OD, OB and OE, by taking sine 45, cos sine 45, sine 60 and sine 30. Okay, from the triangle OCD we have sine 45 equal to OC by OD. From that, OD equal to 2.82 meters. Then from triangle OCB, then OB equal to 2.309 meters, and from triangle OCA, OA equal to 4 meter. Okay, after finding all the length dimensions, then we have to find out the P forces. Then, if the truss is externally or internally indeterminate with two redundants, follow the same procedure. So, first step is the determinate truss with given loadings, that is called P forces. So, I am removing OA and OB redundant, then draw the remaining truss with the external load. Then find out the member forces, that is joint O. Here we have FOC and FOD and a 40 kilonewton load. From that, FOD equal to 0 and FOC equal to 40 kilonewton. So these are the P forces available here. Then next step, that is a determinate truss with the redundants. So we have two redundants, one is R1 and the other is R2. So I am going to take OA as R1 and OB as R2. So consider the first redundant R1, that is called K1 forces. Okay, then draw the truss, remove OB, only draw OA. Okay, give OA as 1 kilonewton member force. So I am giving OA as 1 kilonewton. Remove the external load, that is 40 kilonewton. Then draw the remaining truss, neglect OB. Then from that I found out FOD equal to 1.22 kilonewton and FOC equal to minus 1.363 kilonewton. Okay, then what is the next step? Determinate truss with the redundant R2, that is assume or provide OB equal to 1 kilonewton, that is to determine the K2 forces. Okay, that is a determinate truss with the redundant R2, that is OB equal to 1 kilonewton, that is called K2 forces. So this is a figure showing K2 figure to get the K2 forces, and here we have no OA redundant. Okay, only OB redundant is there, and I am giving the value of OB as 1 kilonewton and find out all the member forces. Here we have FOB equal to 1 kilonewton and FOD equal to 0.707 we get, and FOC equal to minus 1.36 kilonewton we get. Okay, then tabulate all the results. That is, here we have 4 members OA, OB, OC and OD, then corresponding length in mm, then the P forces. Here VA and OA and OB are the redundant, so there is no P forces for OA and OB. Then OC equal to 40 and OD equal to 0 kilonewton. Then K1, it is OA, we assume OA as 1 kilonewton and we found out OC and OD, and K2 forces we assume OB is equal to 1 kilonewton, we give OB equal to 1 kilonewton and again we found out OC and OD. Then find out PK1L by AE. Here we know that A and E is a constant, so so there is not necessary to consider A and E for the remaining columns, so we can neglect A and E. Then find out PK1L, okay, and also PK2L, then K1 square L, K2 square L, then K1 into K2 into L. So these are the columns in the trusses having 2 redundant. Okay, then consistency condition. So consistency condition in the direction of OA, that's equal to summation over PK1L by AE plus summation R1 K1 square L by AE plus summation R2 K1 K2 L by AE equal to 0. This is a consistency condition in the direction of OA. Okay, that means displacement due to P forces plus displacement due to R1 forces plus displacement due to R2 forces is equal to 0. That means while considering the member OA, we have to consider the effect of P forces, then R1 forces, and also there is a displacement in OA due to the R2 forces. So all that displacement at OA equal to 0. Here A is a constant, so we can neglect the term A. Then remain, that is summation PK1L plus summation R1 K1 square L plus summation R2 K1 K2 into L is equal to 0. Then substitute the values of PK1 L, summation PK1 L, then summation R1 K1 square L and summation R2 K1 K2 into L. So we will get an equation in terms of R1 and R2. Put it as equation number 1. Okay. Then next consistency condition in the direction of OB. Okay. That means summation over PK2L by AE. Okay, that is for second redundant. Then plus summation over R2 K2 square L divided by AE plus summation over R1 K1 K2 into L divided by A. Here we are using R1, that is the displacement due to the redundant R1. So this is the direction in case of OB, that is displacement due to the P forces plus displacement due to the R2 forces plus displacement due to the R1 forces is equal to 0. Here also A is a constant, so we will get an equation in terms of R1 and R2. Put it as equation number 2. And by solving equation 1 and 2, we will get R1 equal to 12.52 kilonewton and R2 equal to 2.67 kilonewton, where R1 is the force in member OA and R2 is the force in member OB. So after getting the value of R1 and R2, we can find out all the forces in every members, that is S is equal to P plus R1 K1 plus R2 K2. So this is the equation when we have two redundants is there. S is equal to P plus R1 K1 plus R2 K2. So this is the last column in the table. That is S is equal to P plus R1 K1 plus R2 K2. So in the first problems, that is when the truss is having one redundant, we have the equation S is equal to P plus KR. Here we have two redundants R1 and R2. So S is equal to P plus R1 K1 plus R2 K2. Then apply the values of P plus R1. R1 and R2 we got R1 into K1 plus R2 into K2. Here we get 2.67. That is the value of FOA. Here we got the value of FOA is equal to 12.52. Okay. Then similarly find out the values of FOB, FOC and FOD. So these are the values we get. So hope you all understood this problem. Thank you.